the spectroscopy, it is the study of interaction between the electromagnetic radiation and the matter. So the matter, it is the, it can be atoms, molecules, or ions. So electromagnetic spectrum. So spectrum basically it is a graph or a plot of amount of light absorbed by as a sample versus the wavelength of light. And that amount of light absorbed is called absorbance. Okay. So spectroscopy, it is the study of interaction between the electromagnetic radiation and the matter. Okay. And spectrum, it is the graph or a plot of amount of light absorbed by a sample versus the wavelength of light. And the amount of light absorbed is called absorbance. Now that electromagnetic radiation. So electromagnetic radiation, it is a type of energy. See, we are sitting over here. So in the environment, okay, it is present, electromagnetic radiation. It is the energy that all around us. It is present around us. And it is a form of energy that has both electric and the magnetic characteristics. So previously, it was said like that electric and the magnetic forces are two separate forces. Okay, it is assumed like that previous, but after the James Maxwell developed the unified theory of this electromagnetism. So in that, see what that electromagnetism states. What he proved is that it is the study of electromagnetism, that the study of electromagnetism deals with the how electrically charged particles interact with each other and with the magnetic fields. Means electromagnetism, it consists both electric part also and the magnetic part. Means the electromagnetic waves, it consists of electric component also and the magnetic component also. And that components oscillate in a planes perpendicular to each other and also to the direction of propagation. That components oscillates means moving forward and backward. Okay, so oscillates in planes perpendicular to each other and also to the direction of propagation. And this electromagnetic radiation travels with the same velocity. It's okay in the vacuum. In the vacuum also, it travels with the same velocity, that is 3 into 10 raised to minus 3 into 10 raised to 8 meter per second. And what is the difference? That these radiations differ in their frequency and the wavelength. Now we will see this. See, the electromagnetic wave, you see the two colors, orange one and the blue. So that orange color, it represents the electric field, and that blue one, okay, that is the magnetic field. So this electric and the magnetic fields in the electromagnetic wave oscillate along the directions perpendicular to the propagation of direction of the wave. Means, see the electric wave, okay, it is like continue, its direction is given in which direction it is propagating. Okay, so it is above and below, and that magnetic field which is there, it is perpendicular, it is horizontal to it. Okay, its direction. perpendicular to the propagation of direction of the wave, magnetic fields. So this is a way that electric and the magnetic fields are perpendicular. Its direction is like this. An electromagnetic wave, see, there is an electric field also and the magnetic field also. Now we will see in detail. See, this is the electromagnetic wave. Okay, so see the middle, that is direction of propagation. Okay, in which direction it is going, and see what is the wavelength. There is a, see the wave, there is a line, okay, direction of propagation. So it's going above, and it's like, see, it's going above and below, like it is. So the above part, it is called crest. Okay, and see the below one, that is trough. So the distance between two consecutive crests or the trough is called the wavelength. See the wavelength, okay? It is the distance between two consecutive crests or the distance between the two consecutive troughs. That is the wavelength. And the frequency. See the frequency. Frequency, it is what? It is the number of complete cycle per second. It is the number of complete cycles per second. Okay. Which is also called hertz. Frequency, it is measured in the hertz. Hertz, this is the unit of frequency. And the frequency and the wavelength of radiation, frequency and the wavelength of radiation are normally represented by the equation, that is nu is equal to c by lambda. To see the structure of this, see the oscillation is what? It's above and below, above and below. Okay, it's like it is oscillating. And the above, when it will go above, that above part, it is like pyramid. Okay, that above part. So it is the crest. Okay, and the when the wave comes below, that is the trough. So the wavelength is the distance between this consecutive crest and or the distance between the two consecutive troughs. And with the frequency is the number of complete cycles per second. Okay, means that wave, how many cycles means per it completes per second. Per second में वो कितने cycles complete होते हैं? That is the frequency. See, frequency, wave cycles passing a given point in a given period of a time. Frequency is nothing but the wave cycles passing a given point in a given period of time. And there is an amplitude also. So amplitude, it is measured between the crest and the midpoint of a wave. See, which is the amplitude? Midpoint of the wave. From the midpoint of the wave and the crest, distance between the midpoint of a wave and the crest. Then the speed of light in a vacuum, it is 3 into 10 raised to 8 meter per second. Now here it is given in the kilometer per second. Okay. So if we convert it in the meter per second, it will be 3 into 10 raised to 8 meter per second. So such type of structure, such type of wave, electromagnetic wave structure is there. Now next, we will see this electromagnetic spectrum. Now see in this, see this E is equal to h nu, okay? We called it as h nu. So quantization of energy. See, the radiant energy has a dual nature. Means what? That radiant energy, it behaves as a wave also and it be also as a particles. So this dual nature explains the different properties of radiation. So this radiant energy is emitted or absorbed discontinuously in the form of a small energy packets, and that called quanta. In case of light, okay, radiation, in case of light radiation, that each quantum is called a photon. So normally energy is directly proportional to the frequency of radiation in amount of energy. See, E is directly proportional to nu. So each quantum of energy has a definite amount of energy which is directly proportional to the frequency of the radiation emitted or absorbed. So E, that energy, okay, is directly proportional to the nu. So we write it as E is equal to h nu. So in that h, it is the Planck's constant. Okay, it is the constant so that it has the fixed value which is 6.625 into 10 raised to minus 27 ergs into ergs second. So h is the Planck's constant. So E is equal to h nu. So in that nu, it is the frequency of radiations and the h is the Planck's constant. Means what is a photon? That in light radiation, the each quantum is called the photon. And what is a quanta? The radiant energy emitted or absorbed discontinuously in the form of small energy packets that called quanta. You see, whenever this energy absorbed or emitted, it will be in the multiples of quantum. Means like E is equal to h nu, then E is equal to 2h nu, 3h nu. Okay, it never be as a fraction of quantum. It should be multiples of quantum. That is h nu, 2h nu, 3h nu, like that. So if there are now two energy states, okay, E1 is there and the E2. So in that, the transition when takes place between these energy states, when the appropriate energy is either absorbed or the emitted. Then according to the Planck, this energy is also quantized. Means what? E1, okay. First, it is the energy state is E1 and then after absorbing energy, it is going to the E2 state. So difference between them, that is delta E, okay, which is equal to h nu. So this energy is also quantized. we will see the electromagnetic spectrum. So, see, there are wavelength. So, the wavelength is expressed in different units in different spectral regions. So, normally the electromagnetic spectrum, it consists of see the various it consists of different energy regions. The various electromagnetic radiations arranged in the decreasing order of the frequency or increasing order of the wavelength in that electromagnetic spectrum. Normally, this electromagnetic spectrum, see the part, uh,